Hello, Honors Algebra 2. It is Friday, April 17th, and we're going to continue in our section 13.6 on the fundamental identities. So this is part 2. And I've highlighted in yellow, once again, our table on page 636. And these are basically the identities that we're going to be using today to prove certain other identities to be true. So what we're going to do is, let's go on over to this page. Okay, so now, oh, there we go. Okay, so today we're going to look at specific strategies for proving identities. And what is an identity? It's a mathematical equation where both sides have been determined to be equal in value. And so we're just going to prove that they are equal in value. And we have over here 8 different rules that we want to use, or ideas and strategies to do this lesson today, to prove that certain fundamental identities are true. Now, number 1, there'll be 2 sides. In fact, let's look down here. You're wondering, what are you talking about? Well, here is an identity that we're going to prove. Okay, we're going to prove that what's on the left side of that equation is equal to what is on the right side. And so what we can do first, one way we can approach it is number 1, we can simplify the more complicated side of the identity until it is identical to the other side, all right? And that's actually what we're going to do in this first one I've just boxed. We're going to take that complicated side on the left, and we're going to prove it to be equal to simply the secant squared of alpha. Number 2, we can transform both sides of the identity into the same expression. We'll do that with our third proof. Number 3, we can express the functions in terms of sine and cosine. Well, we're going to do that with the first example also. We're going to look for expressions in which the Pythagorean identities can be applied. And those are the bottom 3 identities that we talked about yesterday, the main one being sine squared of your angle plus cosine squared of your angle is equal to 1. Number 5, we can use factoring. Yes, you can factor a trigonometric expression. An example would be, we know that the sine squared of an angle x is equal to 1 minus the cosine squared of that angle, because if you rearrange that, sine squared plus cosine squared equals 1, our basic fundamental Pythagorean identity. And look at that, 1 minus the cosine squared of x right here. What is that? That's the difference of 2 squares. And so it can be factored to 1 plus cosine x times 1 minus cosine x. So that is a possibility. Okay, let's go to the next one. The next one is we can combine terms on each side of the identity into a single fraction. We'll use that method here in a minute. Number 7, we can multiply one side of an equation by an expression equal to positive 1. Okay, we can do that, and we're going to do that in our second example. And number 8, you never, ever, ever work across the equal sign. So you would not, for example, do cross multiplication, and we'll be tempted to do that here in a minute. Now, let's go ahead and look at this first proof. We are told that the left side is equal to the right side. Okay, so that is an identity. The left side equals the right side, but we have to prove it. So what we're going to do here is we're going to, there's several ways to do this. Let me go ahead and erase this. There's several ways to do this, but what we're going to do, just to see how it works, let's take our number 3. Okay, we're going to express functions in terms of sine and cosine. Now, before I start changing this tangent squared of alpha into the sine squared over cosine squared, let's look over here what our goal is. Our goal is to get the secant squared of alpha. Now, if you go back and look at your Pythagorean identities, you can see that the second one is 1 plus the tangent squared of alpha is equal to the secant squared of alpha. So I already have the tangent squared here. If I could get this box section to equal 1, I could then have an answer. I could do tangent squared alpha plus 1 is equal to secant squared alpha. So let's go ahead and see if we can do that. That's going to be a good strategy. So I'm going to go ahead and erase this part, and let's go ahead and we're going to leave the tangent squared alpha alone. We're going to leave it alone because our goal here is to get this second part, these second two terms to combine to equal 1. So let's go ahead and say, what is the cosecant squared of alpha? Well, let's use our reciprocal function that the cosecant is 1 over the sine, and so the cosecant squared would be 1 over the sine squared of alpha. And then I'm going to put a minus sign here. And then the cotangent squared of alpha, how can I express that in terms of sine and cosine? Well, remember, the tangent is sine over cosine, so the cotangent would be cosine over sine, but it's going to be squared, isn't it? Because it's cotangent squared. All right. So that's my daughter-in-law. Sorry about that. Okay, now, ooh, what do we see here? I see a common denominator. So let's go ahead and rewrite tangent squared alpha plus, and let's create a fraction here. Remember, number 6 said combine terms on each side into a single fraction. So we're going to do it just with these second two terms on the left. So I have 1 minus cosine squared alpha over sine squared alpha. Well, what is 1 minus cosine squared alpha? Well, look at your first Pythagorean identity. Sine squared plus cosine squared equals 1. So 1 minus cosine squared is going to equal sine squared. And so I have the tangent squared of alpha plus the sine squared of alpha. This all equals sine squared over the sine squared of alpha. Now, you don't have to keep writing equals secant squared alpha all the way down the side over here. You don't have to do that. So don't worry about that. We're just going to go ahead and get the left side to equal secant squared alpha. So now I've got the tangent squared alpha plus 1. And what is the tangent squared of alpha plus 1? I've run out of room, but it is, I'm going to squeeze it in here, the secant squared of alpha. And so there is my proof. I have taken this more complicated left side and used some techniques of using my Pythagorean theorem, my Pythagorean identities, excuse me, and putting things in terms of sine and cosine and combining into a fraction, and I have come up with the left side proven to be equal to what's on the right side. Okay, now let me go ahead and erase a little bit of this so I don't look too crowded here, and let's move on up to, and let me get rid of that. Let me move on up a little bit here. Let's see if I should be able to. Okay, there we go. All right. Now, it's going to go back down. Well, so that's the way it goes. All right. Now, let's go ahead and prove that 1 over the 1 minus cosine t over sine t equals sine t over 1 plus cosine t. Okay. Now, remember, let's go up here to number 8. Never work across the equal sign. So we cannot cross multiply here. We cannot cross multiply. So what I'm going to do, it doesn't really matter. Both sides are about as equal in complexity. I am going to take the left side of the equation here, this left side, and see if I can make it equal to sine t over 1 plus cosine t. Now, I've got 1 minus cosine t. If I go ahead and multiply that, let's go ahead and rewrite that fraction. I've got 1 minus the cosine t over the sine of t. If I multiply 1 minus cosine t times 1 plus cosine t, I'm going to be able to factor that to the difference of two squares. So what do I do if I add 1 plus cosine t to the numerator? I'm going to have to add it to the denominator. So let's go ahead and see what we have here. We have 1 minus cosine squared t. I'm just foiling the top two binomials. And down below, I'm going to still leave that as sine t times 1 plus cosine t. All right. Now, what is 1 minus cosine squared t? Well, I think we are understanding that we're going to see that a lot. That is equal to the sine squared of t. So I'm going to come up here, and I'm going to make that equal to the sine squared of t over sine t, 1 plus cosine t. All right, now, what does a sine squared over a sine give me? The same thing as an x squared over x. It just gives me the sine of t over 1 plus the cosine of t. Well, 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 well. What do we have here? We have now got the left side of the equation equal to the right side of the equation. And I have proved this. All you're doing is just writing steps for homework. You don't have to, you're not solving anything. You're just making one side equal to the other side using logical steps. All right, let's try one more. Now, we've got the cosecant of x minus 1 times the sine of x plus 1 is equal to the cosine of x times the cotangent of x. Now, this is one of those where it might be a good idea to go ahead and take both sides of this and see if we can have them equal the same thing. So let's take the left side first, and let's go ahead and FOIL it. So I'm going to have the cosecant of x times the sine of x for my first term. My outer term is going to be plus cosecant x. My inner term is going to be minus sine x. And my last term is going to be minus 1. Okay, well, what is the cosecant of x times the sine of x? Those are reciprocals, and so their product is 1. So I have 1 plus. Now let's go ahead and write the cosecant of x in terms of sine or cosine. Well, we know the cosecant of x is 1 over the sine of x. Okay, and then I have minus the sine of x minus 1. Well, look what's happening here. 1 minus 1 is 0. And so I end up with 1 over the sine of x minus the sine of x. Okay, so let's just leave the left side like that. And now let's go to the right side. Now, normally I would put a little line here and do this on the other side, but I'm out of room. So I'm just going to take my work that's supposed to go over here and put it down here below and see if I can get to this same expression for the right side of my equation. So what I have here is the cosine of x times the cotangent of x. Well, let's go ahead like we did before and make everything in terms of sine and cosine. So let's go ahead and leave this, the cosine of x. I should have used equal sign, shouldn't I? All right, cosine x. Now the cotangent of x we learned is going to be, instead of sine over cosine, it is cosine of x over sine of x. All right, so now what do we have here? We have the cosine squared of x over the sine of x. Now let's keep going. Let's do everything now in terms of sine so we can see if we can get to like the other, this top box simplification or expression. All righty, so what do we know cosine squared x is? It is Pythagorean identity 1 minus the sine squared of x over the sine of x. Oh, I think things are looking really good here. Let's split this up into 2 fractions. 1 over the sine of x minus sine squared x. Well, let me just write that. Minus sine squared x over sine x, which is going to give me for a final expression sine of x minus 1 over sine x minus sine x. And look at there. It matches perfectly with the left side that we simplified. Okay. Now, there are no answers for this in the back of your book because there's actually more than one way to get to the answer here. There's definitely more than one way to do it. But what I'm going to do is I'm going to take a photo of the answer book, and I'm going to just, so you can follow along with the steps if you get stuck. okay? Now, if your method of doing it is legitimate, you've used identities that you know to be true to get to the, to prove that one side is equal to the other, that's great. But if you get stuck, you will have these answers to help guide you through the proof. So I will attach that to the assignment page. Okay, well, I hope you have a great day. You can come see me at Zoom if you need some extra help. And you do have all I'm giving you today is 31 through 38. There's 8 proofs here to do, 8 proofs. And then we're going to have our quiz on 13.3 through 13.5. That will be due by 9 o'clock this evening. Please try to get that in by 9 o'clock this evening. I know it's a Friday, I'm sorry, but I didn't give you a whole lot of homework, so hopefully you can get that done by 9 with no problem. Well, I will see you on Monday. Have a great weekend, and come see me during Zoom at 10 if you need help. If you also need help before you take the quiz, that's fine too. But please don't open the quiz if you're going to come ask questions during the Zoom meeting, because I can't really answer questions once you've looked at the quiz. Okay, but it's open book. It's open book and open note. Have a great day, and I will see you soon. Or not see you, but talk to you soon. Bye-bye.